shift micro operations used for serial transfer of data, also used in conjunction with arithmetic, logic and other data processing operations. The contents of the register can be shifted to the left or to the right. As being shifted, the first flip-flop receives its binary information from the serial input. Three types of shift: logical, circular and arithmetic. The types of shift operations are based on the what is the data or bit passed through the serial input or the serial input. That determines the shift type. So consider this is a register R, R0, R1, R2, R3 and Rn-1 that indicates the individual bits. And this is shift right. We are shifting in the right direction. Then the serial input will be given here and the data will goes out from the register through the serial output. Okay. Then shift left. Serial input will be given through the least significant bit part and the data will goes out from the register through the serial output. Logical shift. So based on the input we are giving through the serial input, we can classify shift operation into logical shift, circular shift, then or rotate operation, arithmetic shift, etc. So first we can consider the logical shift operation. Transfers 0 through the serial input. Logical shift right means R1 gives SHR. SHR is the register transfer logic notation. So R1 gives SHR, shift right R1. Same register will be here R1, R1. Then logical shift left, R2 gives R2 gives SHL, means shift left R2. It means the same register here also. So this is the diagram, indicates that 0 will be the input, serial input. The registers will be shifted in this direction and the data will goes out from the register through the least significant part. So R1 gives SHR R1. This will indicate a one bit of shifting. Shift the register R1 by 1 bit position towards right. And this indicates shift the register R2. Register R2 towards left by left. Okay, assume that this is our R2. These are the bit positions. This is actually bit position. Okay. Then this 0 will be given here. Serial input is here and serial out will be through here. The circular shift or rotate operation circulates the bits of the register around the two ends without loss of information. Circular shift right, that is R1 gives CIR, that is circular shift right R1. Then circular shift left, R2 gives CIL, circular shift left, then R2. This is the register transfer logic notation. Then the circular shift left can be represented like this. This Rn-1 will be fed into R0, or the most significant bit will be fed into the least significant bit position. The circular shift right can also be indicated like this. That's just a reverse. See? From here to here. Okay. That is the least significant bit position will be given fed to the most significant bit position. Then in some machines there will be no instructions like micro operations like CIR, that is circular shift right or circular shift left. A shift micro operation statement must be accompanied with another micro operation that specifies the value of the serial input for the bit transfer into the extreme flip-flop. So in that case, in that system, a normal shift micro operation will be followed by, or will be along with that micro operation, we have to use some other operations, and we can specify the circular shift operation. For example, circular shift right, we can express like this, that is shift a register right, then an-1 gives A0. Similarly, circular shift left can be expressed like this. A gives SHL A, shift left A by 1 bit position, and A0 gives AN minus 1. Okay. Arithmetic shift. Shift a signed binary number to the left or right. An arithmetic shift left multiplies a signed binary number by 2. Example R1 ASHL, arithmetic shift left, that is a register transfer logic notation. So R1 gives ASHL R1, and that will shift by 1 bit position. An arithmetic shift right divides the number by 2, that is R1 gives ASHR R1. An overflow may occur in arithmetic shift left and occurs when the sign bit is changed. So this indicates arithmetic shift right, that is the most significant bit will be given or fed into the sign bit will be fed into the register while shifting. From here the bits will go out. So this can be used for sign extension also. In some cases we have to use sign extension. In that case sign bit will be fed into the, we will shift the register and the sign bit will be fed or extended. Then arithmetic shift left, that will be same as the logic shift left. There is no difference. Only difference in arithmetic shift right. Then consider a shift micro operation. We can consider an example. R1 is the content of R1 is 1100 110 110. Okay. Then after arithmetic shift right by 1, this will become 11100 Arithmetic shift right by twice, this will become 11110011. Okay. Shift micro operations hardware implementation. A possible choice for a shift unit would be a bidirectional shift register with a parallel load. But it has drawbacks, needs 2 pulses, the clock and shift signal pulse. No efficient in a processor unit where multiple number of registers share a common bus. It is more efficient to implement the shift operation with a combinational circuit.